If I've got a set of keys being swung around in a vertical circle, or a roller coaster going in a vertical circle, or a bucket of water going around in a vertical circle, we want to be able to analyze two extreme points of that vertical circle, the top and the bottom. There's two forces acting in both cases, the normal force and the force of gravity. They both act down when we're at the top. At the bottom, the force of gravity acts down, but the normal force will act up toward the center. What's next? In either one of these questions, what would I do next? What did I do in my last unit, my dynamics unit, when I had to combine multiple forces like this, Braden? Well, we just did, yeah. But after we do the diagram, what do we do? Janae? Go ahead. Yeah. Yeah. F net is equal to? Yeah, it's the sum of the forces Fg plus Fn. Now, Braden, you kind of jumped the gun there a little bit because your next step is the centripetal force, you said. Right? The net force is the centripetal force, which is, of course, force of gravity, which is m times g plus the normal force. By the way, does the mass cancel there because it's in both sides? No, it doesn't. How come it doesn't cancel despite the fact that it's on both sides? Yeah. Yeah, it's three terms, and it doesn't only appears in two terms. So if it appears in both terms on the right-hand side, yeah, we could cancel it, but not here. By the way, the bottom looks exactly the same, at least so far, right? F net is equal to Fg plus Fn. We're going to say mv squared over r, again, is equal to Fg plus Fn. Now, we go to subnumbers in, and it's only when we go to subnumbers in that we have to start worrying about signs. When are things going to be positive and when are things going to be negative? Gravity at the top of the circle is going to be what? Positive or negative? Negative. Normal force at the top of the circle is going to be negative because it's acting down. The centripetal force will be? Well, the centripetal force is the net force. If both of the forces that contribute to the net force are down, then the net force will be down, so therefore it's going to be negative. Good. Now, what about the force of gravity when we're at the bottom of the circle? It's going to be negative again. What about the normal force when you're at the bottom of the circle? It's going to be positive. And what about the centripetal force when you're at the bottom of the circle? The net force, the centripetal force. If you're at the bottom of the circle and you're going around in a circle, the net force or the centripetal force points toward the center, and the center is where relative to you at the bottom? Up. That means the centripetal force will be a positive value. Remember, we don't worry about the signs until we sub in numbers, but once we sub in numbers, they're very important. Okay, if I make the centripetal force negative when it should be positive, my answer is going to be completely wrong. Now, usually we end up solving for the normal force here. Not always, but usually we end up solving for the normal force in these questions. What's another name for the normal force? Yeah. It could be the tension. If I'm swinging my keys around in that vertical circle, then I could be looking for the tension of the string. That's the same thing as normal force. Maybe you even want to call it Ft. That's fine. I usually just keep calling it Fn just to be consistent, though. Yep. Oh, sorry? No, Fc wouldn't be the normal force. No. As long as there's gravity, Fc won't just be the normal force. There's always going to be gravity combined there. Maybe the force of the track, which we could also call Ft. Okay, yesterday when you were on the mind bender at the top of the loop and the bottom of the loop, the track was pushing on you downwards and upwards at the top and at the bottom. That's the normal force. You're asked to solve, in a couple of the questions in the book that I gave you earlier today, you're asked to solve for the normal force or the force of the track pushing on you at the top of the circle and at the bottom of the circle. You're going to solve for Fn in that case. What's another term that means the same thing as normal force? You saw this in our last unit with elevators specifically. How heavy are you really compared to how heavy you feel? Your actual weight is the force of gravity, right? Your apparent weight is the normal force. So I don't ask you, I don't believe in the assignment booklet for your field trip yesterday, your apparent weight anywhere. But I do ask you for the normal force or the force of the track. And that's the same thing as your apparent weight. If the normal force acting on you is 2,100 newtons, then that means that your apparent weight is 2,100 newtons. I do ask you several times for the number of G's, the number of G forces that you experience. Now, this would be a smart thing to write down, because this is a fairly common question that I get over the next couple of weeks, usually before the assignment is due. To find the number of G's, you want to divide how heavy you feel, which is your normal force, by how heavy you actually are, which is your force of gravity. So for me, once again, my force of gravity is about 700 newtons. How heavy I feel might be 2,250 newtons. My normal force, 2,250. If I want to find the number of G's that I experience, how heavy I feel relative to how heavy I am, I would divide 2,250 by 700. 750. What did I say my weight was? Let's say it was 750. My apparent weight was 2,250. Then the number of G's that I would experience would be 3. Right? How heavy do you feel versus how heavy you actually are? All right? Now, what I'd like to do right now is to take a look at one question, just to kind of get your mind back into it from that worksheet that I gave you last week, and then we'll move forward and focus on some new material, kind of shift gears a little bit. The question that I want you to work on here is question number 13 on that worksheet, the 100-gram set of keys question. You want to find the tension in the string. What are you really looking for? F what? FM? Fn, yes, Fn, the normal force, right? Or if you choose to call it Ft, that's okay too, as long as you're solving for that one variable, regardless of what you actually call it. All right, so when we do this, let's say question number A, or question A, we draw a free body diagram of the object, the keys at the top of the circle. This is going to be Fn, this is going to be Fg. We're going to say F net is equal to the sum of those forces, Fn plus Fg. And then mv squared over r is equal to Fn plus Fg. Fn plus m times g. Let's sub in some numbers. We've got a 100-gram set of keys, so we're going to make it 0.100 kilograms times the speed, which is 3 meters per second. Now, if you look at the assignment booklet that I gave you for your field trip yesterday, by the way, your radius is 0.45 meters. If you look at the assignment booklet that I gave you for your field trip yesterday, you get a question like this to solve. You have to solve for the tension or the force of the track or the normal force at the top and at the bottom of the vertical circle. But you're not given the speed. Any suggestions as to maybe how you'd find the speed? Like, what did you measure yesterday for that roller coaster loop? That middle upside down loop. What did you measure? 2 things. Anybody remember? Maddie? Yeah, you measured the radius and the time. So if you need to find the force of the track or the normal force acting on the card at the top or the bottom, you need the speed. You don't have it? How are you going to find it? V equals d over t, kind of, but a special form of that. V equals 2 pi r over t. So if you don't have the speed, that's fine. Get it. Get the speed, and then go from there, sub it in, and do what we're doing here now. Solving for Fn, remember, m times g, force of gravity, 0.100 times 9.81. Now let's worry about positives and negatives here. The centripetal force at the top of the circle should be negative because it's acting down. Normal force should be negative as well, but we're not worrying about that because we're solving for that, not subbing in numbers. The force of gravity should be negative because it's down. Let's calculate this force here now. On the left-hand side, we've got negative 0.1 times 3 squared divided by 0.45. That gives me on the left-hand side negative 2. And when I multiply 0.1 times 9.81, I get negative 0.981. Now I'm going to say negative 2 plus 0.981. It's a negative on the right side. Take it over to the left by adding. I get 1.02, or we're just going to make it 1.0 actually. Fn is equal to 1.0 newtons, negative 1.0 newtons. Right? Now, if we were to do the bottom, here all we change would be this. This would be a positive value then, right? This would still be negative. That's still going to give me 2 on the left-hand side, except it's going to be positive 2 instead of negative 2, equals Fn subtract 0.981. And I'm going to take this to the other side, and I get the normal force is equal to 2.981, or rounded to 2 digits, that would be 3.0 newtons. Okay, how many people got negative 1 and plus 3? All right? Now, I haven't asked you this, and I won't give you a question like this today, because we've done enough of this now over the last little while. But I'm just going to ask you quickly what you would do if you were asked to solve for the minimum speed at which this roller coaster, or which these keys or whatever, can go around the track without falling out. Where would you analyze, firstly? The bottom or the top? Never going to be in the middle, right? Because the extremes are the top and the bottom. Where are you going to analyze, top or bottom? Right? You want to find the minimum speed, top or bottom? Top. Yeah, if it's going to fall out, it's going to fall out at the top. So, excuse me. So at the minimum speed, what are you going to do? How is a minimum speed question different than what I did here first in question A? One thing you got to remember. That's it. Good. Fn, when you're looking for minimum speed, Fn would be equal to 0. So in other words, mv squared over r would be equal to m times g for min speed. That's it. Turn around and solve for v, and you're good to go. Min speed or max radius. I think on the assignment that I handed out a little while ago, there's a question that you're asked to solve for minimum speed, but not for maximum radius. But it ends up being the same question. Set Fn equal to 0, solve for v or r, as the case may be.